Hi guys, how are you doing? This is Teacher Smile and welcome to our today's lesson in Euclidean Geometry. What we are going to talk about is this theorem which says that a line drawn from center perpendicular to a chord bisects the chord. We are going to try to analyze and understand what this statement of the theorem is actually saying. Well, the terms that are used in this theorem are a line drawn from center, so a line from center perpendicular chord bisects. These are the terms we need to understand for this theorem. So you already know what a line is, and we just need to look at this circle. I mean, we need to briefly look at what a circle is. So allow me to explain to you a circle. This is what we call a circle. Well, something like that. And the middle of that circle is called the center, usually labeled O, but can also be labeled whatever. Now, if there is any line that is drawn from center to this part, circumference, is called radius. I've already said this distance right round here is called circumference. Circumference. So a radius is a line that is drawn from center to circumference. If there is any line that is drawn to join from center to circumference, then it is a radius. If there is a line that is drawn from circumference, passing through the center to the circumference, this line is called diameter. Diameter. Now, we can see that if there are two radii, which means that radius and radius, it can form a little pi here. This little pi is known as sector. And the distance of the circumference only in that region, this circumference in that region is called arc. Well, if I draw any other line anywhere else from circumference to circumference, not necessarily passing through the center, this is called a chord. And a chord divides the circle into segments, minor segment and major segment. So when I have a circle like this and I draw a chord, this is our chord, then this one is a minor segment and this one is a major segment. Now we understand what a circle is. Let's now try to understand the terms of our theorem. So a line drawn from center, it means that I will have a circle, of course. Then I have a center. And then there is a line that's going to be drawn from that center. Let's say this is O. And that line from center is going to be perpendicular. Perpendicular means at 90 degrees. So it's going to be 90 degrees to a chord. Remember, a chord is a line that is drawn from circumference to circumference, not necessarily passing through the center. But any line from circumference to circumference is called a chord. Chord. Even a diameter is a special type of a chord because it's coming from circumference to circumference. So perpendicular means 90 degrees. So let's say this is M and our chord is AB. The theorem says that then we bisect that chord. This line that we're talking about bisects that chord. What is to bisect? To bisect is to break into two equal parts. Two equal portions, two equal parts. You know, bi means two, right? Break into two equal parts. So OM is perpendicular to AB. OM is a line drawn from center. And AB is a chord. And that line from center is perpendicular to the chord. Then OM is definitely breaking AB into two equal parts. It means that this first part is equal to the second part. This is what the theorem says. It says that then AM is equal to MB. Again, a line drawn from center, which is OM, is coming from center because our center is O. And then that line is perpendicular to the chord, which means that it's 90 degrees. It's 90 degrees when it gets to a chord. And this is the chord AB. Then it bisects the chord. Maybe to just understand it better. We are saying we may have a line from center. Let's say we have a circle here. And we have our O here. But this line is not perpendicular to the chord. And let's say this was P, this was A, this was B. In this case, AP is not equal to PB because OP is not perpendicular to AB. Therefore, OP is not bisecting AB. The statement of the theorem is saying these parts will be equal only if we can see that the line from center is perpendicular to the chord. But if we just have a line from center and that line is not perpendicular to the chord, this theorem does not hold. So we need to understand this firmly, that a line from center perpendicular to the chord, if that line is 90 degrees with the chord, then the chord is being broken into two equal parts. But if the line from center is not 90 degrees, it's not perpendicular. If it's not perpendicular, then whatever the chord we have, whichever chord we have down here, is not being broken into two equal parts, is not being bisected. I think it's very clear, so we need to understand that. Okay, I hope I have explained enough about this theorem. See you again in the next theorem.